In one previous lesson, we introduced the concept of trigonometry, and we saw how trigonometry helps us in our daily life. We also talked about the different applications as being engineering, as being survey, as being navigation and architecture, just a few. Now, today, we would like to look at a very specific concept about the right-angled triangle, which is the concept of the theorem of Pythagoras. And that will come immediately as I share with you this screen, which introduces us to the concept of Pythagoras what? Theorem. Right, there we go. So now one thing we noticed is that a right-angled triangle is a triangle with one side being 90 degrees, or with one angle being 90 degrees. Now notice that A, B, and C are known as the different lengths of the sides of this right-angled triangle. And notice that this small square right here is called, or forms the 90 degree. And because of that, this is called a right-angled triangle. Now, Pythagoras theorem states that this length of the longest side, okay, the length of the longest side of a right-angled triangle, when squared, will give us the square of the sum, rather the square of A, this one side, and plus the square of B. In other words, just put it right down. Pythagoras theorem states that C squared, where C in this case is the what? Where C in this case is the length of the longest side of the triangle. So we have C squared, all right? C squared equal to A squared, okay, plus what? Plus B squared. Plus B squared. That is Pythagoras theorem. Now, notice that from Pythagoras theorem, we can then develop a separate formula to find, well, C. Notice that from here, from this expression alone, we can find the value of C. A lot of time we are not looking for C squared. We want to find the value of C. And then how do we find the value of C? Well, to find the value of C, we must get the square root of the quantity on the right-hand side, okay? And to find the square root of the quantity on the right-hand side, we get the square root of A squared plus what? Plus B squared. And that is how we find the value of C. But Pythagoras theorem is this, which is right up here. I just highlighted it. Now, the other thing we also want to include is, how do we then find the value of B? How do we find the value of B? Then later, how do you find the value of A? Now, notice that from Pythagoras theorem, which is what we have here, if we are interested to find the value of B, that is to find B, or rather A, let's start with A. If we are requested in finding the value of A, then what we are going to do is we will first make A squared the subject. And what that means is we have to transfer B squared to the left-hand side. And so A squared will be equals to C squared minus B squared, okay? That is A squared will then be equals to what? Will then be equals to C squared. We are using the Pythagoras theorem, this one, to help us find A squared. We will start by finding A squared before we can find the value of A. So A squared in this case is going to be C squared minus what? Minus B squared. So that is going to be the expression for what? For A squared. And so C squared minus B squared. So what do we get from there? What we get is the value of A squared. Then now, how do we find the value of A? Now, to find the value of A, we need to get the square root of C squared minus what? Minus B squared. And how do you do that? Well, we will then say in the next step, A, this time not A squared, just A. So A is going to be equal to the square root, okay? It's going to be equals to the square root of C squared minus B squared. That gives us the value of A. Now, in the event that we are required to find the value of B, we will first start by finding the value of B squared. And how do you find the value of B squared? Well, using this Pythagoras theorem, to find the value of B squared, we will write C squared minus A squared. Then B squared will be on one side of the equal sign, okay? So B squared is going to be equal to C squared minus A squared. That is, we transfer A squared onto the left-hand side, onto the side where there is A, rather where there is C. So that will give us, well, B squared on one side of the equal sign, okay? We'll be having B squared on one side of the equal sign. That is B squared on one side of the equal sign. And on the other side, remember, you can put it on the left-hand side or on the right-hand side. There is no problem with that. It will not affect your final answer. So we will say B squared equals to C squared minus what? Minus A squared. So let's put this down. C squared minus what? Minus A squared. Minus A squared. Just a minute. Trying to locate some tool here. Yes, there we go. Okay, so that's what we got. Now we will have to write A squared right away there. So now that we have got A squared, the next thing we want to find is what? The next thing we want to find is the value of B, because we have now got B squared. So the question is, how do we find the value of B? Well, to find the value of B, we will have to find the square root of the quantities on the right-hand side, which is C squared minus A squared. And so we say B is now going to be calculated from what? From the square root of C squared minus what? Minus A squared. And that is how we calculate the value for what? That's how we calculate the value for B. And we have got, well, we have got from Pythagoras theorem. Let me just highlight that one. This is Pythagoras theorem. I'm going to give it red. Yes, Pythagoras theorem can help us to find A. Okay, can help us to find A. And also we can use Pythagoras theorem to find B. Okay, that is to find B. So to find B, we still use what? We still use Pythagoras theorem. All right. So this is how we calculate the value of B. All right. So now, how else can we use Pythagoras theorem? Well, let's look at a few practical examples right here. On the next page, right away. So here we are supposed to find the length of the side marked X. So notice that in the first diagram, or in the first right-angled triangle, X is the longest length. And in the second triangle, right-angled triangle, X is also the longest length. But in the third triangle here, this is supposed to be our number 3, triangle 3. You notice that this is not the longest length. It's probably B or A. Well, whether it's B or A, we can still find that value. So how do we get started? Well, to calculate the first one, The longest length is x, which in our case was c. So we will move up right away and we do what? And we find the value. Rather, we find from Pythagoras theorem, we would like to use this expression, which helps us to find what? C. So C is our longest length. In this case, it's x. So we'll come right here and we will say for question one, the longest length is x and our longest length is c. So we just substitute and we say, well, this is now going to be x for this case. And now A in this case is 15 and B in this case is what? In this case it's 8. Yes. So from here we can find an expression for what? An expression which will give us the value of x. So what are we dealing with? Well, we are dealing with the square root. The square root of what? The square root of 15 squared plus 8 squared. What will that simplify to? Let's see. We are going to be having, well, using our calculator. Just put here calculator right away. Just a minute as my calculator pops up. Right, so our calculator has come. Well, what we would like to find is the square of 15, that is 15 squared. Then we will have to add this to 8 squared. 15 squared plus 8 squared. What do we get for that? Well, we get 289. Yes, that is what we get, 289. So what is the square root of 289? Well, the square root of 289, let's check the square root of 289. Where is our square root? Yes, it's 17. It's 17. So the square root of 289 is 17 in centimeters. That is how we find the value of x in the first question. Now, the other thing that we also want to include is the second question. The second question also requires us to find the value of x. Now, notice that in the second question, well, the second question is right here instead. This is the second question, this is the third, this is the fourth, and this is the fifth. Well, in the second question, x is right up here. Let's compare with our drawing and we see what x is representing. Now, when you look at this first drawing, x is represented by A. And because x is represented by A, we will use the what? We will use the formula which we had already got to calculate A. So we will come right down here and we will say, well, in the second question, this is the formula that we have to use. And now, A is what we are calling x. What is C going to be? Well, C, which is the longest length, in this case is 20. And so we put it right inside here, 20. And then B is this other one, which is 9 what? 9 centimeters. And so where there is B, we put 9. Now from here, we can then find the what? We can then find the value of the squares of 20 minus the square of 9. So what will that be? Well, that is what we are getting into. So from here, we then have to find the square root of what is 20 squared? Well, let us see right here. So we'll be having 20 squared And what is 20 squared? 20 squared is 400. 400 minus what? Minus 9 squared. 9 squared. Notice that 9 squared is 81. So 20 squared, which is 400 minus 9 squared, which is 81, must give us a value of 300 and what? 319. And so right inside our bracket here, we'll be having 319. And from here, we can find the square root of 300 and what? And 19. So we now find the square root of 319, which in this case is 17,86, rounded to 2 decimal places. So this is going to be 17, what? 86 centimeters, rounded to 2 decimal places. Now, the next thing we want to look at is the what? Is the third question. Now, the third question, which is right up here, would like us to find the value of x. Now, notice that x in this case represents the longest length, which is c. And so we will go and find from our formula for c. Where is the formula for c? Well, this is the formula for c. So from this formula for c, we can find the value of x. Well, let's have it right here. So as question 3, this is the formula we are going to use. This formula is going to help us find the solution to question 3. Now notice that x in this case is what we are representing with c, and so we have to put it right away. Now what is a going to be? Well, a is going to be 6,5 and b is going to be 10,2. Now notice that even if you exchange their position or you interchange their position here, it will not affect the final answer. You could say a is 10,2 and b is 6,5, or you could say a is 6,5 and b is 10,2. What you will get as your final value for x will be the same. So let's substitute a with 6,5. So a in this case is substituted with what? The 6,5. Then b is substituted with the 10,2. All right. Now from here, we can go ahead to do what? We can go ahead to find the value of what is inside the square root sign. How do we do that? Well, we will then say this is going to give us the square root of, we have to find the square root, rather the square of 6,5. So with our calculator, we get 6,5. Let's first clear this. 6,5 squared. Now, to 6,5 squared, we will add 10,2 squared. Now, when we square 10,2 and we add it to the square of 6,5, we get the square of 10,100. Rather, we get 104,04. Now, that's what we put right inside here. It's 104,04. So what would the value of this quantity then be? Well, the value of this quantity will then be calculated with ease when we find the square root of what we have just got. So we put the square root sign. Oh, sorry, not like this. We are going to put, and first clear this, we are going to put the square root of 1. Let's just put 104, comma, 04. Then we put square root sign. Yes, that gives us the value of 10,2. That gives us the value of 10,2. Yes, as the square root of the value that we calculated. Now notice that this is going to be what? In centimeters. Just a quick check. Would like to check for this value, to be sure that this is what we had got. This is 319. Let's see the square root of this. Yes, that is fine. And to check with the upper one, let's see what we are going to get. This is 2, 8, 9. The square root of it is 17. Yes, that's what we get. Well, now the next question is what? Is question 4. Now, question 4 requires us to find the value of x. Now, notice that question 4, which wants us to find the value of x, the x in this case, if we compare it with what we have in the diagram here, x in this case is b. And so we need to use the formula for finding b. So the formula for finding b is right here. This is the formula that we use to find b. Now b in this case is x. Notice that this is the solution to question 4. So b in this case is x. What is c in this case? C represents the longest length, which in this case is what? Which in this case is the longest length, which in this case is 10,5. Then this other length for A, which is 8,4. We substitute them right inside there, 10,5 for C. So we'll be having here 10,5. Then for A, we have 8,4. Yes, that's what we have. 10,5 for C and 8,4 for B. We can then go ahead to calculate what? To calculate the value of x. How do we do that? Well, we will need to get the square of 10,5 and later the square of what? 8,4. So we put this inside the square root sign. Then with our calculator, we put what? 10,5. So let's see what we get for 10,5. So we have here 10,5. Okay, we have to square this 10,5. Then later we add what we have got. No, we're not adding. We subtract 8,4 from what we got. 8,4 must be squared. So we square 8,4. Now notice that when we square 10,5 and we square 8,4, we get the difference of the two. This one must give us what? 39,69. Now we get the square root of that. That gives us what? 6,3. So inside here we write 39,69. 39,69. That's what our calculator is giving us, 39,69. Then the square root of this value is what? Is 6,3. So the square root of this value gives us 6,3. So 6,3 is the value of x in what? In centimeters. Then now the last question in this case is question 5. Now in question 5, we are also supposed to find the value of x. Now notice that the longest length in this case is 13, and that is C. Now this one here is like our B, and this is like our A. And so to find the value of x, we will use the formula for A. Notice that even if we take the formula for B, we will still get the what? The same answer. Here we are taking the formula to calculate A. So this is the formula we use. And this is what? This is question 5. And so this is going to give us x equals to C. What's the value for C in our original question? Well, the value for C is 13. And so we write 13 for that. Then for B, we have what? We have 5. And so B is 5, and we substitute it right there. So from here, notice that we are going to get what? We are going to get the value of x when we substitute nicely. And so what is this going to be? Well, this is going to be the square root of, what is 13 squared minus 5 squared? We use a calculator for that, so that we get 13 squared. Now notice that 13 squared is 169, but from it we have to subtract 5 squared, which is what? Which is 25. So we write 5 squared which is 25. We subtract those two values to get 144, and we write 144 right here. Now notice that this value, which is 144, can be simplified when we get the square root of it. So we get the square root of 144, and that gives us a value of 12. And so we write down 12. Now notice that 12 is the value of x in centimeters. And yes, the thing you want to be careful about is mainly C. If you can identify C nicely, if you can identify the longest length nicely, then calculating A or B will not affect, will not disturb you. The only time when you will get a wrong value of x is when you don't substitute nicely relative to C. If you can identify C, which is the longest length, nicely, then calculating A or calculating B will not disturb you, because even if you interchange the value of A and B, there will not be any much problem. And yes, this is where our lesson stops.